All right, the next thing we're talking about is the moon. Now, the moon is interesting in itself because of its relative size compared to the other planets into Earth. Meaning, it has a mass of 0.0123, the mass of the Earth. Okay? And it has a diameter of 3,476 kilometers, which is about 1/4 the size of the Earth. Or the easiest way to think of it is it's about the size of North America, all of North America. Okay? And because of that, it's large as in that there's other moons that are larger, but it is one of the top 7 or 8 largest moons in the solar system. But it's going around Earth, which is not one of the bigger planets. And so you would expect all the big moons to be around bigger planets. So the relative size between the moon and the Earth, it's very close, even though it is still only 1% of our mass. Now, its density is lower than the other planets, the other terrestrial planets, at 3.34 grams per cubic centimeter. Remember, Mercury and Venus were up around 5. We think there's a reason for that. Gravity is 0.17 Earth's gravity, or you weigh about 1/6 what you would here. And its rotation period is 27.3 days, but its synodic period is 29.5 days. And its revolution period is also 27.3 days. What does all this mean? Okay. Synodic period is by phases. So if you go from full moon to full moon, it's about 29.5 days, close to 30, which is where our months came from. But rotation period is how long it takes to spin once on its axis. Now, this is confusing a little bit because we aren't used to this idea, but here is the moon. This is a globe of the moon. And this matches here. This is the side you see. This side of the moon is facing the Earth, is now facing you in the camera. That side is the only side we ever see from Earth. So what happens is, imagine I'm the Earth, this is the moon. We only see this side. I can't see this side at all. So as it rotates around like this, I am always facing the same side of the moon. But you're out there in space somewhere, so you're looking at the back side of the moon now. Then you see half the back, half the front. Here you see the whole front. Here you see half the back, half the front, and then the back again. So you saw it actually, you saw all the sides of the moon, so you saw it rotate once. But if the rotation period and the revolution period are the same, that means what we have a term for that, we call that tidally locked. So that one side always faces the planet. Think of it as ballroom dancing, where you're always facing your partner. You spin around, but you're always facing your partner. That is the case, and it wasn't until 1959 that we had any clue what the back of the moon looked like. In fact, before that, there was all kinds of speculations, and that's where the term the dark side of the moon came from. It's actually no darker than the front, but there were legends that there was evil places with creatures flying around, all kinds of crazy things. But in 1959, the Russians sent a probe around the back of the moon and took pictures of it, and that's the first time we learned at what the back of the moon looks like, which is pretty impressive because by 1959, the U.S., we hadn't even got rockets that we weren't blowing up on the pad at that point. So they were way ahead of us in the beginning. They had satellites in orbit. They had already gone around the back of the moon, and we were just barely trying to get satellites up into space at that point. All right, so basics of the moon is that it looks like this, and where's my Well, let's just talk about it. There's two basic things you see here. You see these darker regions? We call these seas. So we see two different types of terrain on the moon. We see the seas, and the other lighter parts are called the highlands. Okay? The seas are darker regions. They're also younger. The rocks are younger in the seas. Okay, and there's composition. These are slightly more dense. It's different materials, different kinds of rock. The highlands are older, lighter material. They're also very heavily cratered. Where these seas tend to be the smoother regions. When the astronauts went to the moon back in the late 1969 through 72, they landed in the seas. In fact, you look over here, this is Mare Tranquillitatis, or the Sea of Tranquility. This is where Neil and Buzz landed on the moon, was in the Sea of Tranquility. In fact, that was one of the first things they said when they got there. Tranquility base here. That means that they're there on Tranquility. The other missions went to different parts of it. Most of them still landed in the seas because it was the nice smooth regions. One of the last ones landed close to the highlands because they wanted to explore, and they took a car up and they went and explored that part. So how do we have seas and highlands? Why is that different? This is the biggest difference between it and Mercury. If you didn't see the seas, you look at all this crater material and say, hey, that looks exactly like Mercury, and it does. In fact, it's close. Remember, Mercury is 4,000 some kilometers. It's close in size to Mercury as well. So they're very similar chunks of rock out there. So how do you create that? Well, let's take a look at what we think the interior of the moon is. Now, the moon has an iron-nickel core in it, and there's some debate about whether it's actually still liquid or it's solidified. It's cooled off and become solid. Then it has this outer region, and then it has the crust. But this is critical here. The crust on the one side is thicker than the other. So see, the crust is very thin over here. This is the direction towards the Earth. This is away from the Earth. So just like all the other planets, Moon started out as a molten sphere. The heavier material sunk down to the core. But because it formed around the Earth, it was still liquid when it was around the Earth before it solidified, the heavier material got pulled towards the Earth, so it didn't center it exactly. The crustal material up here then was offset. So we have a thin crust on this side, we have a much thicker crust on the other side of the moon. And then remember when we were talking about the Mercury, you were talking about there was lots of cratering going on early on in the solar system. 4 billion years ago, there was stuff getting battered all the time. All the planets got battered, okay? But what could happen here is originally this mantle in here was a liquid magma. I mean, when it formed, that was just liquid rock. And so when a large object hit on this side, it could actually go all the way through into the mantle, and then all this liquid rock would flow up here and solidify and smooth it out, and it would form a sea. Now on the back side of the moon, the dark side of the moon, which is not dark, when it hits, it wouldn't penetrate all the way through, and so we don't see many seas on the back side of the moon. So the reason we have these seas is because the crust is thinner on this side, and it was the lava that flowed up, and that's why the lava's there in the lower region. The lava flowed up and smoothed it out. But it smoothed it out after the heavy bombardment. Remember, early in the solar system, there was lots of cratering. After that had kind of tapered off was when all this smoothing occurred. That's why there's not as many craters in these areas, because it's a much younger rock on the moon. All right, here's another picture of the moon, similar. This is the back side of the moon. And you see that the backside is very heavily cratered. There's only a couple of C's, not many C's, on the back. Because the crust was so much thicker on the back, there wasn't the lava flowing up from the mantle to fill in the low regions. So the backside of the moon is very heavily cratered. It's also interesting to note that when you get to the backside, you see all these craters. Most of the large craters are all named for Russians because they were the first ones to take pictures of it, so they named them all for Russians. So if you look at the backside, they're mostly named for Russians. All the craters are. All right, and when we look at craters, this is crater Copernicus, named after the astronomer. There's also crater Tycho. Those are some of the more famous craters on there. This one, right here, you can see, it's very large. It's about 100 miles across, so it's a very big crater. You can see the central peak. You see it's fairly old because the edges are kind of soft. These secondary craters are younger, right here. But this is typical of what the terrain is, and that's why they were orbiting it. Now remember, the moon has no atmosphere, okay? So you can orbit it very low because you don't have to worry about the atmospheric drag, so you can orbit it and take pictures from a fairly low position around the moon. It's good in some ways for scientific purposes. It would be a great place to put a telescope. Remember, the biggest problem we have with the telescope is our atmosphere. Well, you put a telescope on the moon, you don't have that problem. All right, we also see a couple cool things on the moon. We see what we call lunar rills. We see these on Earth too, but the lunar ones are very interesting. See this right here? It looks like a river.